Hi, this is the Kubernetes Workgroup Device Management meeting for Tuesday, October 15th. I'll share the agenda. There's just a few items. Okay. So I just wanted, before Polly, I hand it over to you. I just wanted to say, great job, everybody, for getting all the KEPs merged last week. We have a lot of work to do, and only a month to do it, but really glad to see we were able to make a lot of progress, at least on the design side. Hopefully now implementation, we can do the same. So thank you all for your efforts. And Patrick, over to you.
Yeah, okay. Well, let's get started with the work that we need to do and how we organize it. The good news is the working group device management label in GitHub now works. There was a small hiccup on the infrastructure where the label was created but was not applied to GitHub, and that has been sorted out. So if you are creating an issue or a pull request and you label it with WG device management, it gets the corresponding label. And I'm using that to update the project board automatically. So anything that appears as new in GitHub shows up as new here in our left column, and we can use this meeting, or I do some triage to decide what to do with it, whether it's something that can be worked on, if it's an issue that is ready to be handled, and then we can move things forward as we are working on them. And related in that context, the first question to the group is how broadly we want to have that label applied. I've seen one issue where someone was using it for something that's clearly a device plugin interface issue, which is something that we with DRA are kind of leaving behind, but I can also imagine that others see it as falling under our agenda, our Carta with device management. So I'm open for both. It's really the question, not what we tell people.
So I think that it probably falls under our charter, and I don't think we're necessarily leaving it behind. It's an alternative.
Sure.
Right? Like
yeah.
the driver makes the decision. It has different semantics. The thing that's a little weird is, right, a working group is a working group to solve some problems and then disappear. So it really, like, in that sense, it's not a new problem, right? It's like, but it kind of falls under our charter. So I think it's, it's a SIG node thing, but if it gets assigned to us, we can at least triage it and send it to the right person. But yeah, it's a little weird.
Yeah.
I'd say it belongs with that label, but it doesn't belong on this board. I don't know how
we can always remove it from the board if we think that it doesn't belong here and we don't want to look at it again. So in the past, I think I've been moving things to a very right column, which is done. Whether it actually was resolved or just closed as not valid or applicable anymore, we could do the same with that one issue. There is one under review.
Instead of moving it to done,
or remove it
to done, could you just remove it from the board?
I think we can. I think we can. So it's the first item under in review. I don't know actually who moved it there. The board is maintained collaboratively, and I don't think we have history tracking of who's making which changes. So I think I didn't move it under review, but someone apparently did. So
no.
or I forgot.
I moved some things to done, but I didn't move anything into review recently.
Yeah. So I think for that issue, Sergey for SIG-Node said that this might be something that we want to consider for DRA, and I agree. It's a race condition. I don't think it applies to DRA. It's as far as I understand the issue, it's about something that Kubelet does. If it knows about registered devices and if it does something too early before the device plugin had a chance to register, Kubelet does the wrong thing. And with DRA, we are avoiding that race condition because we don't do anything with a claim or a port that needs a claim until the device, the DRA driver has registered. So I don't think this race condition that is described here applies to us. So we can just say we ignore this issue and leave it to Signode to fix it.
Okay. I think Sergey's suggestion here is that we. Am I on mute? No. Okay.
No,
No, we
I think
can-
Sergey's suggestion here is that we ensure that we have tests for similar race conditions, which is a slightly different thing than saying this specific issue. So we might want to make sure that we have appropriate tests for that.
And
it sounds
test
like
for
that should be
restart is
spawned
very
off.
hard.
That should.
Yep.
Sorry, you can say we should spawn off a new issue for that, and not link this issue on the board.
Okay.
Sure.
Sorry, I interrupted someone. Go ahead.
Was that? Sorry, too many windows open here. Yeah. Okay. So we want to spin off a new issue for that rather than. Okay. Well, if somebody could do that offline, or if I don't, was that Sergey I heard talking? Is he on the call?
Yeah, it was me.
okay.
I can see if it applies, and if it applies, I can issue. It's really hard to test restarts, so
Right.
you need to understand what's actually needs to be tested.
Okay. Okay. Thank you.
I think
no-
the closest that we could have is schedule a pod and then make sure that the driver is not running and that the pod gets scheduled as soon as the driver comes online. And I think we have such tests.
Okay. Okay. Well,
I'm pretty sure we have E2E tests, and there might even be E2E node tests for various failure scenarios, and I think that's covered.
okay. Yeah. Well, if we can just create an issue that says verify that there's those tests, and then we can move this to done from that. Just we'll leave it there as a reminder for now. It doesn't really belong in review, but
Yeah. Okay.
I'll put it in progress anyway. Awesome. This is great, Patrick. So maybe, yeah, as part of our routine, then we should probably groom this backlog and go through these and make sure things are on as you suggested.
Yeah. I've been doing that from time to time, but I think it hasn't been seen wider participation. So we might make it an agenda item for this group here. I think it's
Exactly, and then
yeah.
that might also encourage other people to jump in and do some work here.
Yeah. Yeah. Okay.
I think you got the next item too.
Yeah, the next one is actually about one column in that board, and that is about PRs that are ready to be reviewed, which goes back to what we need to do next. I think I created a few that was where I tried. Yeah, it actually works. The link works. So that filters basically out one column and focuses on that one. That is my impression of, or my proposal to the group, how we should organize our work for 132. I would prefer to get the classic DRA removal done first. And I think, John, you reviewed, Kevin reviewed, some various other people looked at it. I think it's ready. We just need now Tim's approval as API reviewer to actually get it merged. Getting it merged will simplify some of our API files, which makes also other changes like beta promotion simpler, because we just don't need to deal with those backward or these things that we want to remove.
Yeah, right. It's a lot less. There's like 15,000 lines you remove or something. So that's a lot less opportunity.
Is there any way you can twist Tim's arm to look at the?
Yeah, I'll do that. I'll talk to him today. Yeah, I'll see.
Yeah.
Because I think once this is merged, everything else is a delta on top of it, and so it helps everything else move along.
Yes. Yeah. I was thinking the same thing.
Yeah. And the next PR is actually a good example. It would have a merge conflict with that classic DRA removal, So what I did today is I just rebased it. The first commit is the classic DRA removal in that second PR, which shouldn't be there, but is there to avoid merge conflicts. And then once the classic DRA removal is merged, I can rebase, and the second PR will just have the actual commits for that change. And it consists of one more API change in the Alpha API. The admin access conceptually should have been recorded in the allocation result in the status, and it wasn't. I think that was just a plain oversight when we did the implementation in 131. So I'm fixing that, and then I've added a second commit for the things that we planned for 132, which is the DRA admin access feature gate implementation for that
To pull it
particular
down to
fields.
alpha.
Yeah, and so it will remain in alpha. It's currently in the alpha group, but it gets its own feature gate, and then when we do the beta promotion later, that field remains in alpha. It's marked as alpha and will not be available if you just enable the beta API.
Okay, awesome. Okay, and then looks like some bug fixes and things. So everything's going to lay on top of number one. So let's get that merged ASAP. Okay.
What's not on the list yet is the beta promotion. I have a slight preference, and I'm being selfish here, to get the beta promotion merged first before the new work that needs to be done in 132. Partly because I think it's the most important thing that we want to land, partly because it has merge conflicts with other things that go into the API. If someone does their work and gets it merged before I'm done with the beta promotion, I have some manual code resolution to do again. It's not the end of the world if that happens, but I must be careful to not miss some new field when creating the beta API. So it's a bit easier if we do the beta promotion first.
Yeah,
And it's mostly
One question I have about
ready.
that.
It's mostly ready. I have a PR, I have a branch where I'm basically putting all the things that it conflicts with, and I just as soon as the other things are merged, I can create a beta PR that is ready.
Are you saying you would think all of these should be merged before that? Or in my mind, it would fit in slot number 3.
Classic DRA needs to be merged. The admin access needs to be merged.
And then I would
The
pick that right
rest-
after that.
Yeah, and the rest, I think it can be done in parallel. It doesn't conflict.
Okay. They just don't conflict at all. Okay.
So the plan should be number one, number two, and then beta.
For
Yes.
merging.
Everything else is kind of priority wise, right? And like ordering in priority wise, but the others kind of could happen at the same time. The ones on the board now.
Yes.
Okay. Yeah. All right. Let's do that. Let's try and get that done.
So one thing I guess, does that mean maybe that all of us that are now building these new features, should we base that off of your branch for the beta promotion so that we don't have to rebase once that's in?
You could, but I will have to rebase my branch, so you will need to be prepared for doing your own rebases occasionally.
I think that's fine though, because I feel like the
Yeah.
rebasing is going to be, the final rebase would actually be harder because we have to move everything out of the V1 Alpha 3 API into the Beta 1 API and all of that. Whereas if we're
you need to basically add your fields in both once I have the beta API. If you want to do that right away, my branch exists. It's the DRA 132 branch in my repository.
okay.
And there is a work in progress PR. I can't add it to under review because it's not ready, but I can add it under in progress. It might be there. Let me see whether I have it under in progress. No, it's not there yet, but I can add it to the in progress column. I just need
Okay.
to find
I think
my-
at least for mine, I'll rebase it on yours unless it becomes a really big hassle. But it's going to need a rebase anyway. So
Yeah, At the bottom of the, no, not ready, next column. At the bottom of the in progress is my 132 API PR.
Okay, here it is. All right. Okay, excellent. Anything else on this, Patrick, or shall we move to Kevin's?
I think we can move on. Yeah.
Okay, awesome. Thank you. Kevin.
Yeah, I mean, mine's kind of optional. If Geeta, I don't know if she wants to go first.
Sure. Thanks, Kevin. Hey all, I'm from the AWS Neuron team. We have a use case that we are hoping to solve with the DRA framework, where we have a scheduler extension today, which tries to allocate contiguous cores. So it's just indexes being contiguous is a good enough test for that, the way the indexes are published. Looks like in the current API, that can't be done based on the way we read the code. So we wanted to consult on that. I also identified a potential to-do that has been identified in the README, which seems like might help. We'll be happy to contribute, but just want to understand if we are thinking right. I'll pause there for any questions I can clarify.
Yeah, I have a question. So when you're talking about CPU cores, you want to be able to use DRA to allocate CPU cores. Is that correct?
No, this is an accelerator hardware. It also uses
okay.
the terminology core. It's called a neuron core.
Got it. Okay, so it is an actual device that what's the system level interface for these? Is it device nodes under /dev, or how do you what do you need to make available to a container to make use of it?
So the way it works today is the device is one resource that is, so in device plugin world, device is one resource that is advertised, and that can be requested by a pod, but we also advertise Neuron Core, which is a subset of that device essentially. And pod can request that and get that. And when you request the subset, you can't just pick any subset. You have to allocate a optimal subset, which is a contiguous set of cores, which we achieved today through scheduler extension.
Yeah, so this sounds like a use case for the partitionable devices kept that I wrote for this upcoming release. It's going to remain in alpha, but me and you should sync and we can work out the details to see if it can solve your use case. But based on what you just described, I can picture how it would, because it allows you to do kind of exactly what you described. Either you ask for the whole thing, or you want some part of it, and you want to be able to group that into some specific shape of what someone that can ask for, and how many of them and which ones they are. And that's exactly what this is designed to do. Basically, if you get the subcomponents, it takes the full thing offline, and now you only have access to the sub pieces of it. And there's different configurations you can put together as to how you allocate those out. And it does so in kind of a nested partitioning way. So, either you get the full device, or you can get some subset of it, or if you could even break those down further, you can do that as well. And then getting those sub partitions takes the one above it offline, and now you only have access to the so I think it sounds like it will match, but and we can work out the details.
Yeah, it sounds totally up in line. What my one question is, how many cores, and is it all subsets of all, like, is it, you can have all the cores, you can have one core, you can have two cores, you can have three cores, and they're all like, it's every contiguous block of them, and how many are there? I'm just trying to imagine number of combinations we have here.
Right. So today it could be, it's a number. So the maximum you can go to is what the device has to offer, or whatever node has advertised. It could all come from one device if the number is smaller, or it could come from multiple devices as well. in either case, we want to allocate the contiguous ones. So there is a topology for the underlying device, and this allocation is basically aligned with that topology.
Right. Yeah, we have a similar thing for TPUs. I'm just curious, like, I'm trying to get an order of magnitude number of devices you'd be advertising from a individual a node. So it sounds like you can even cross, like, so where it might get tricky, if you've got 4 of these chips or 8 of these chips in a node, if they can all be used as one, then you probably have to treat them all as one device and everything underneath it as partitions of that device using Kevin's functionality.
That
Like,
kind
that
of
would
approach
work.
might work out. Yeah, that's one way to approach that.
Because of the
Yeah.
nesting you can do.
Yeah,
Yeah.
because of the
Sorry.
cross device connectivity.
Gita, one of your colleagues contacted me over
Yes.
direct message this weekend, and he showed me a diagram that had a 4x4 grid of cores, so that would be 16 total. That's kind of a manageable number. If it was, say,
In one
I don't know,
device, yeah.
Yeah, if it was 60 by 16 or 128 by 128, the numbers of combinations would probably explode and not fit into the partitionable device model. With 4x4, I kind of can imagine that the partitionable devices support actually can work. The other thought that I had is that this sounds like a problem for scoring, or perhaps even filtering based on the numbers of devices that have been selected and based on some criteria. We don't have scoring right now, but I could imagine that it could get added in such a way that a cell expression looks at a potential combination of your cores and says, this is not possible at all, give it a score of -1. This is less optimal than some other thing, and this is best combination. That might work for a larger number of scores, but we don't even have a design yet. So I think partitionable devices is indeed your best bet at this point.
Okay, so I think we will sync up
Yeah.
offline on Slack to understand next steps and how we can contribute. One last question on this is, there is a to-do you have identified. Let me quickly grab you the link.
While you're doing that, I put the link to the cap in the chat here.
Yeah, so in the chat, I put link in there. There is a potential future extension identified on device constraint. Oh, it doesn't let me paste the picture. If you click on the link in the chat, and John, can you click on the link in the chat?
Oh, sorry. Yeah. Well, I did. It's just bringing up the. Okay. Yeah. I wasn't sharing that tab. Okay.
And just search for potential future extension. Just a search on that. It's in the device constraint that's called out. I wanted to ask if this can help. Potential future extension. It's in the device constraint struct. Sorry, I should have used the one with line numbers.
It's okay. In this
Extension, potential future extension. Yeah, that.
Yeah. That is
this
similar.
one.
That's similar to scoring. I actually, in my mind, what I just described is kind of a combination of both. So this match expression is just a Boolean that says, yes, this combination works at all, and the scoring would be for picking up a better one. So yeah, both this match expression could work. I think it would. We just need to figure out what that expression is and what checks.
So we just missed the design deadline. So this won't get into 132. But if you're interested in pursuing this feature in 133, I would encourage you to write a cap, and it's certainly a very doable thing. It would well, we'd have to think through what the implications are.
Sounds good. We will connect offline then. Thank you.
Awesome, thank you. So this raises another issue that there's an issue around some failures. I think it was in device plugin, Sergey, but we're gonna and you tagged me on it around DRA, where somebody is using thousands, I believe, or maybe even tens of thousands of devices on a single node by subdividing their 80 gigabyte NIC into the 80 gigabyte GPU into 1 megabyte slices or something. And
Yeah, I commented on that one after you. I don't know if you saw my response there.
no, I haven't seen your comment yet. Okay. I wanted to raise it as like, we're going to have to put some constraints on this, at least at the testing level, if not at the code level, because that's going to, that's not going to fly for DRA for sure, trying to navigate that tree of 80,000 devices.
Yeah, my comment was basically the encouraged way of doing sharing is by a user-mediated sharing in DRA rather than system-mediated. And so you can actually get what he wants with a single claim that you then tell all CUDA clients that attach to this should only get 1 megabyte. And then you point your devices at that. Sorry, you point your containers at that. And at the system level, it will make sure to divide it out that way, but not at the allocation level. The allocation will give you a full device, or will allocate a full device to the claim, and then different clients that attach to it, something running behind the scenes will be the one that limits the amount of memory that they're able to actually consume from it. So from
Okay.
the scheduler's perspective, he's only allocated a single device. Yeah.
Right. So you're able to help him solve his use case, but which is great, but the point I'm raising is like, we need to put some testing around and some constraints and some recommendations around. I think we have a thing about scalability already in there for GA criteria, unless I'm thinking of a different cap, because I look at a lot of caps. But just something to note that this raised. Sorry. Okay. I think.
I was going to say one more thing to that. Sorry.
Sure.
Sergey. We've also talked about adding another device type that can be advertised in a resource slice, which isn't just list everything out. It'd be a more compact representation, which might be, there's 100 of these, and whatever these is defined by some template that looks identical for every single one of them, but there's a count field that says you can allocate up to this many of this, and here's what they look like. And then that would, draw the, it would mean that you don't, the resource slice doesn't blow up and the scheduler doesn't have to do much. It just read a single device and it's just doing some accounting based on that count field rather than something more sophisticated. And, if it really is a device that's being divided this way, all its attributes likely stay identical too, right? Like in terms of GPU, it would be the same UUID, it would be the same everything. There would just be something that said how many of these you get access to.
Yeah, it's a sort of like device plugin device model, like, right? It's like just a count. And we have a similar thing if you think about virtual interfaces on NICs. So like not VFs, but like VLAN interfaces that get built on top of a NIC, a VF or something. You don't know how many there are. Like you can't enumerate, the 4,000 VLANs or the 16 million VXLANs or whatever it is, right? So, so it's almost a function to create devices. So I think there's a few other interesting device models. Like right now we have the basic model and we have the partitionable model that Kevin's working on. And these are other models, the way we've structured the API such that you can create other models that satisfy other use cases. Sergey?
Yeah, I just want to ask Kevin if do you think we need to support this scenario for device plugin, or just tell that device plugin won't scale to that number and you need to wait for DRA? Because I really don't want to go into this business.
Yeah, no, the device plugin, the interface between the kubelet and the device plugin is very simple. What's advertised to the node object is a count, but the kubelet and the device plugin share a giant list of all the devices that could be allocated. And that's where this complication comes in. The interface there isn't a count. It's a give me a unique ID for every device that could ever be allocated. And so these messages get really big if you have thousands and thousands of devices that are being advertised there. And I don't think we want to change that, not for the device plugin. It would be a complete redesign of the way it works, and there's no way to have extension points like we do in DRA to support different models. That's the model for the device plugin, and there's nothing else. I don't think we want to support there. We would say migrate to DRA if you want to do that. Speaking of which, we're not there yet, but I think there's a way to potentially, in the future, use a DRA driver, but allow it to say this collection of devices should be advertised as extended resources connected to this device class. And now you can ask for something like a GPU via the normal nvidia.com/GPU, but the scheduler will be able to pick that up, allocate it like it does for normal DRA stuff rather than the device plugin way, and then trigger the DRA driver to actually do the allocation behind the scenes. I haven't worked out a full design for this, but it's something I think we should seriously consider for 133 so that, people can start deploying the DRA drivers, completely replacing their standard device plugin ones if they want, but user applications don't have to change at all.
That would be awesome, because it also means that you can mix and match, right? One of the issues we have right now is your either device plugin or your DRA
On a given node.
So that would be super awesome. And then if we need the less, like if we need the decision made in the driver rather than in the scheduler, then we can use what you just described, where we have a new device model that just advertises a count, and that would allow the driver to have the flexibility to make choices about specific devices. So we can
the
get it all.
scheduler would then still, exactly, and the scheduler would still be able to, recognize it as having been advertised as a standard extended resource rather than a resource claim.
Yeah. Fantastic. Great idea. Okay, awesome. I think Kevin now.
Yeah, sure. Kevin Hannon. Yeah. Can I go? I'm going to go ahead and share. I'll give a quick little demo of what I've been working on.
Congratulations, by the way, Kevin, for the leadership.
Thank you. Could someone give me access to share?
Yeah, 1 second. Let me remember how to do that. I have to go make co-host. All right, there you go.
Okay, thank you. So yeah, what I've been working on is just trying to kind of evaluate how DRA could be supported in Q. I've drafted a pretty brief KEP in Q to kind of walk through this, and I'll give a demo first, and then I don't know if I'll go through the text.
Can you make that any bigger, man? That's really tiny.
All right, I know a better way to do this. I mean, I'll just go to the demo because I wanted to kind of show an example. So what I've been doing is playing around with the DRA example driver and just trying to see if I can get that working with Q. The idea that I think I got from Patrick and others is that, so for those of you who are not familiar, Q has this concept.
Here you go. Yep. I was going to have to make it bigger.
Okay, is this good now? Okay.
Yes.
I'm zooming in. Okay. So basically, Q, the thing that's I think relevant for DRA folks is we have this cluster queue, which kind of defines quotas at a cluster level. I think you can limit it to many namespaces, but typically these are cluster available. And then the idea that I was rolling with was you can kind of give resources like this covered resources, and then this is a DRA. Like if for those who are not familiar, the DRA example driver kind of just I think creates this dummy device called gpu.example.com, and then I can add a quota limit on that, and then basically nothing really changes on the workload level other than for Q, you would actually reference a local queue. And then, when you create this, I think this one will actually work. yeah, this one will work. And then the way that queue works is it kind of translates workloads into a queue object called a workload. So jobs will get translated into this workload. And then when you look at it, what it's really doing is kind of translating when you create a job, what kind of pods are actually being created. And this is actually kind of saying like, you know, these are these examples like gpu.example.com and then resource usage. And then it kind of sees whether or not your workload can be emitted. In this case, this workload is emitted because I'm using one request to a gpu.example.com. So then it is emitted. Just for fun, I'll delete this one. So what I'll do is I'm just gonna. Okay, I have one example here. So GPU test 1. I'll just go ahead and bump this to 2. So this will create 2 pod sets. And then you can kind of see here what's happening is that I don't have enough quota for my device class for gpu.example.com. So then the queue won't admit that workload. So that's kind of just a very quick update on what I've been sort of kind of working on the queue side. I'm still waiting on reviews from the queue folks on this idea, but I was kind of curious from the DRA folks, is this a good path to go down?
All right, that looks pretty good to me. The one thing I thought was a little weird was the like I couldn't differentiate between, you know, GPU dot whatever you had and like how do you know that's a device class versus an extended resource versus, you know, something else. So
Built-in resource.
Yeah, I mean, yeah, that's a good point. We were kind of in the KEP, I think we talked about like the issue in Q tends to be that these are core resources, like and I'm kind of jamming the DRA names into that. And then for cluster queues and Q, I don't think there's no reason why I need to make a distinction, but I do think that probably makes sense to kind of say that this is a dynamic resource versus a core resource.
I guess my question is like, and Patrick may know directly the answer, like when we add the resource quota must designate, like the quota must designate that it's for devices somehow, like as opposed to like a quota for an extended resource, which must look different in the resource quota API. And so I'm wondering how that difference translates back into Q. If right now it's just saying resources, right? Then it's looking at the resource list, and the resource list is just a fixed name, and we're not part of the resource list, like we're a claim. So one of the things we talked about, I think Kevin's got a better solution with what he was talking about a few minutes ago, Kevin Clues, with as far as combining a DRA plugin and device plugin. But one of the things early on we had sketched out, like, oh, we don't want people to use claims because they're complicated, or we want, you know, to make it as easy as it used to be to do, you know, GPU or NVIDIA.com/GPU. We want it listed in the same place. Maybe we'd say device class : foo, you know, I want 5 of those, and we would be able to draw down on a device class in extended resources without having to have the extra boilerplate of claims and all that stuff. That could be done with a webhook or something like that. So it's kind of a tangent, but what I'm saying is, like, we were thinking about ways in which the resource list API as it exists today could be used to manage
devices from a
devices out of claims, and you kind of have the same problem here. Now, I don't know if it's a good idea or not, but you could just like literally prefix those names with device class : and then the device class name, or you need to make that more expressive API and have a second field where you can sort of say, this isn't just an ordinary resource that would be in resource list, it's something else.
Yeah, and I think that's probably where we would end up going in Q side once this enhancement freeze season is beyond us. I will probably get some reviews from the Q folks on this one. But yeah, I think that makes sense. Like we want to be able to distinguish between dynamic resources and core resources and extended scheduler resources like GPUs. Yeah, and so I think that makes the most sense, and I'll probably try to. I think that probably is the best bet to go forward with. Even if it was kind of informational at this point, that's why I kind of dropped it from my POC. But I think it makes sense to at least have that in there anyway.
It's awesome to see it in a POC just working, right? It's very cool.
Yeah, and I guess the thing that I'm still very confused on. Like when I declare, and I think Patrick was trying to explain this to me, but I'm still confused on it. For device claims, like if an init container and containers and sidecars are using a device, I don't count those as physical, like extra requests to a device. Like is it at most you can only have one device request per pod?
You can share an individual. So the device request is what allocates the device. And then the association in the container spec associates individual containers with that same device via the request name, the internal pod spec request name. And so like
there's not a new device allocated. That's the thing.
Exactly.
So
there's not a new
bound
device.
to the claim. It's set in that claim, not bound to a container.
So from a resource quota point of view, it's really that you allocated the once. Whether you use it 50 times in the same claim or you use it even 50 times across different pods, you allocated it once. So it's about the claim allocating the device of a particular class is how the resource quota, I believe, should work. And Patrick,
Which is different than how the device plugin works, right? The device plugin, devices get bound to a container. The container puts the request in, the device plugin binds into that container, and only they have access to it. In the DRA world, that's not the way it works. They get bound to claims, and then anyone can reference that. But the quota and the counting of that resource being allocated is only to the claim and to nothing else.
Okay, so then for quotas for DRA, it's not, you don't really need to even look at init containers or containers. It's just whether or not it's actually in the claim of the pod spec. Like that, the pod spec is allocating that, and then everything in the containers will be reusing that request.
In fact, it maybe breaks the model a little bit because it's not per pod. So if you allocated a claim and shared it across pods, resource quota wise, you'd be using one, right? Not n for each pod.
Where at the point where you have a resource claim template, then you can treat it as a per pod resource that needs to be allocated anew for each pod that gets created. And that's probably the most common case. So I think on chat, I suggested that if you encounter a resource claim template, you can just count it by as a pod resource, because that's in practice what it is.
For each pod, it'll instantiate a new claim, which then gets a new GPU or whatever bound to it.
Okay. Yeah, I feel like I did this a few weeks ago now. I already forgot. I have to look at like what the APIs I was using for Q. I think I did use resource claim templates. Yeah, I think that makes sense.
Then you would have unique ones per pod.
Okay. All right. Well, thank you all for.
I think Mrunal has a question too, Kevin.
Yeah, so I think this is more broader. Thanks for the demo, Kevin. So this is more a broader question. Like, do we imagine a future where we want to have a quota in Q saying, I want to restrict by, say, the attribute? Like, I want to allow this user only 5 A100s, for example, or I want him to use only up to 500 GBs of GPU memory. And that means like maybe evaluating the cell on the queue side and then figuring out a quota mechanism.
But I think the answer is yes. The ideal interface from all of our internal users is they want to be able to do quota on amount of GPU memory. They don't care about how many devices or what device type it is. They want to limit by how much memory gets allocated. And we've talked about, I'll let Patrick expand on it, but we've talked about ways to do that by moving the decision about quota from admission time to allocation time. But it's a break from the way quota works today. And so there's been some pushback on that.
The
But
interesting
if we did
observation
that,
is,
we can. All good.
yeah,
Go ahead.
I was just saying that, thinking that Q doesn't need to wait for core Kubernetes to implement such a quota mechanism. Q could already do it today in whatever description or specification you want to come up with for this aspect of quota management. It wouldn't be enforced by Kubernetes itself, but only in Q. But I think my understanding is that this would be okay because you wouldn't admit more pods to be scheduled than can run.
Yeah, we think this was kind of a motivation of like from the InstaSlice side, we kind of wanted to translate like to stop like requiring people to say like I want 2 slices for MIG, rather start having like GPU memory, and then in Q we're kind of translating. It's kind of a little bit of hacky because we're saying pod requests still need to ask for MIG, but then the Q quota could translate that to how much GPU memory you're actually putting in and have a quota on that. Or that's kind of, I think, the approach we're taking from the InstaSlice side with Q. And that's kind of at least the idea. And then obviously DRA is a little bit separately from that also.
Yeah, with DRA, I think we'll need a way where we can like reach into the quantities that are there in the devices and somehow like expose them out so we can have a quota.
And we can do that, and we've talked about different ways of doing it, but there are, it's a little bit, yeah, there's just issues to resolve, right? There's decisions to be made. Like if we do it at allocation time, so somebody asks for 4 gigabytes, but all that's available is an 80 gigabyte GPU, I guess we give it to them, but then, does that count as 80 gigabytes against our quota or 4? In volumes, for example, it would count as 4. Right. So, but it's a little bit, it's just hard, right? It's just, we just have to make decisions, and they're probably going to be wrong for some use cases, no matter what decision we make. So, I'm not sure what to do. So there's a Patrick, you created an issue, I believe, or maybe it was Kevin, to kind of further this point. So we can find that issue and people can comment on it. We can start.
Yeah, maybe if we can gather the use cases, it'll help us narrow down what is an MVP.
Yeah, and I think for Q, I was kind of going to go with the structured parameters beta, and then ideally start iterating on the newer ones that are coming up, just because like it's already enough. Like it actually brings up an interesting point around how do out of tree components consume DRA for testing, and like I was kind of going to go with the DRA example driver. But that does mean that we're kind of following probably N-1 releases, which makes sense. Like Q is not going to build against development 1.32. It's going to be testing with 1.31. So that's at least like kind of probably one step I'll be talking a lot about in Q is how do we actually build end-to-end testing with DRA, and like what we're able to actually to use to test this stuff. Which is probably
okay
on that side.
With that said, I think I would like to come to the next topic because it nicely follows to what you just said. I remember that I wanted to bring it up. I added to the agenda doc, and that was about developing DRA drivers that work with Kubernetes 1.31 and 1.32. And perhaps related also the question whether we shouldn't be more proactively and more forcefully asking for backports of bug fixes into 1.31. So the current situation is we know about at least one bug that would be worthwhile to backport to 131 for people like you with Q who are developing against a stable release. And this is blocked by the policies in Kubernetes that doesn't allow backporting fixes for alpha features. So that's one thing.
I wouldn't say doesn't allow, I'd say not encouraged.
I think it was blocked. It was actually not blocked. It was blocked by Aldo. He didn't want that to be backported based on those policies.
Well, we can, I don't know what the decision-making process is there. We can see if there's what we can do. It's probably up to the release team, I would guess, who's releasing the older releases, but I don't know for sure.
Yeah. So but the other part that I wanted to discuss is with the upcoming promotion to beta. I'm going to change the staging repo, the dynamic resource allocation, and in particular the resource slice controller and all the helper code that we are publishing there for DRA driver vendors. And once I do that, anyone consuming the new package, the new release of that staging repo, will only be compatible with Kubernetes 132 because that's the only release that has the beta API, and that helper package is tied to that version. So a DRA driver vendor has two choices if we go ahead. They can stay on the packages from 131. Then they are compatible with 131 and 132. But 132 only if the alpha API gets enabled, which we are trying to discourage, or at least not actively. Well, it would be supported. It would be there, but you would have to enable an alpha API while there is already a beta API, which isn't ideal. The other choice is you link against the 132 package, and you are only compatible with 132. With the beta API in that release.
That's what I'm doing.
The implication is that for vendors who want to support both releases, you have to maintain branches. Because I don't think you can import, well, yeah. I think one of my colleagues came up with a creative approach for importing the same package under different versions, under different import paths with replacements. It was a bit hacky. I was wondering whether we as upstream should put some effort into this particular helper package to make it automatically work with both APIs. It would be extra work, extra complexity.
This is a short-term problem. 131 is a beta. It's an alpha release. I don't know. I think we can put it on the list. I don't know that it should be a priority, given our other things.
I don't think it's worth it. I don't know how many vendors there really are out there, and I know that I don't care about 131. I'm already linking off the packages from Master, and that's what I'll be using in the driver.
Okay. Yeah, that's the kind of opinions that I was hoping for, but is that worthwhile? Is it not worthwhile? And it sounds like it's not. Okay.
Well, I guess this does bring up, for MIG or other new features for DRA, I'm imagining, or are we proposing those features to the V1 alpha for DRA, and then they'll have to kind of pick and choose which ones to use, whether beta or alpha, for new features for DRA? I guess that you would probably expect people to use them until they get promoted to beta anyway.
Well, they'll be in the beta API, but they'll be behind a feature queue, if that makes sense.
Because of the way the Kubernetes APIs work, right? They have to be in the new fields to an existing API. They're alpha fields in an existing beta API.
Okay. All right. So we're not proposing new alpha features, like a V1 alpha for DRA or anything anymore.
Not for the API.
Okay. All right then. Never mind.
Okay.
Yeah,
awesome.
but I think that the really conclusion is here. everyone should try to stay on the latest Kubernetes release. And even if you're if you depend on these experimental things, you absolutely need 132. There's 131 is kind of there, but don't expect much support for it going forward. And as Kevin said, the NVIDIA driver might not even support it anymore, not with the latest code.
Yeah, I
Historic
mean,
release
to be
probably work, but they are archived, I guess, and will not get more attention.
Yeah, so to be clear, going forward from after this release, we will remain backwards compatible with everything, but it's not worth the effort in our driver or I think in upstream Kubernetes to try and maintain this. How do we support both 131 and 132 at the same time when, we've always said 131's alpha, we can throw it away. I get the arguments of being able to experiment with the stable branch for now, but that's only a problem for the next 2 months, right? So I
Yeah.
don't think it's worth it.
Okay, awesome. Anything else, or shall we wrap up 1 minute early? All right, thanks everybody.